What if we could estimate dental age without using Gustafson's 6 criterion or its modification? Let's revise the other important histological approaches. First, dental translucency. With increasing age, root dentin gradually becomes more translucent, usually beginning apically and extending coronally. The extent of this translucent zone can be measured as its length or depending on the technique, which is its area. The basic principle is simple. Greater root translucency generally indicates greater age. However, the result can vary with tooth type, measurement technique, and age group. Second is secondary dentin deposition. Secondary dentin continues to be deposited throughout life, gradually reducing the size of the pulp cavity. Therefore, the amount of thickness of the secondary dentin or the corresponding reduction in the pulp space can be assessed for age estimation. This can be evaluated histologically or through imaging depending on the method. Third is cementum. Cementum continues to be deposited on the root throughout life, so age can be estimated by assessing cementum thickness or by counting incremental lines, which is also called cementum annulations. But remember, counting cementum lines does not always correspond exactly to chronological age, so standardization is important. Fourth, dentin and cementum fluorescence. Dentin and cementum shows measurable age-related changes in their fluorescence. Researchers can measure fluorescence intensity, spectral characteristics, or even how quickly the fluorescence decays. However, the direction and magnitude of the change depend on the tissue and measurement technique, so fluorescence is mainly a specialized research and forensic approach rather than a routine standalone method. These changes can be observed using specialized light sources such as ultraviolet light. However, this is more specialized and is mainly used in research and forensic application. Next are microscopic approaches. Light microscopy provide basic visualization of dentin, cementum, and incremental structures. Polarized microscopy can enhance the visualization of certain structural features. Scanning electron microscopy provides much higher resolution of image of surface and microstructures. And confocal microscopy can provide optical sectioning and three-dimensional information from suitable specimens. Histomorphometric analysis. Instead of simply looking at a microscopic section, histomorphometry converts microscopic structures into quantitative measurement. For example, researchers can measure features such as secondary dentin, cementum, or extent of dentinal translucency. This makes the assessment more objective and reproducible than simple visual scoring, although it requires specialized preparation and analysis. So remember the six approaches: dentinal translucency, secondary dentin, cementum, fluorescence, microscopy, and histomorphometry. Next, we will move from what we see under the microscope to what we can see on X-ray.